Swayam Prabha. Digital India. Educated India.
Greetings to everyone present here. Now I am here to introduce Professor B. Ravindran, who is a remarkable achiever in the field of data science and artificial intelligence. He is the head of multiple departments in IIT with an academic background from institutions like the University of Massachusetts, Amherst, and IIT Bangalore. Now I request everyone to give a round of applause and welcome our professor and get enlightened with his teachings. Thank you, sir.
AI today, right? So, a bunch of different things. So, I'm not going to get into the nitty-gritty details of it. So, there is enough material online if you guys want to go and learn things on your own later. This is just to get your interest going, right? So AI is really affecting everyday life, right? Okay. So, good, I have one screen on which I can do this. So, if you are following me on that screen, note that I'll point here. Fine. Let's go. So AI is affecting everyday life. So how many of you speak to an AI on an everyday basis? 5, 6. So what do you do? Huh? And something, yeah. See, so it's become so commonplace that many of us are actually interacting with AI systems on a regular basis, right? If nothing else, I use Alexa to turn off the lights after I go to bed. I feel too lazy to get up and turn off lights, right? So it's come to a point where it's become so convenient for us, and it's not just in all of these things, right? In fact, it's affecting every field. So the first one is an AI system helping crack a hard to solve theorem in math, right? This is chemistry. This is physics, that's biology, right? It's completely revolutionized certain areas in biology now, right? So people don't, so there is this, about 10, 15 years ago, right? So our telescopes had become so powerful, right? So the amount of data that was being pulled in by a telescope, right, was so humongous that no human could actually look at that data and make any sense out of it, right? So it's almost 2 decades now since when astronomy, right, became very much a computer-driven field, and ironically, that is happening to biology now, right? So we have so many instruments and so many ways of doing things that the amount of data that we pull in, even from studying biological systems, is so vast that you cannot even traditional computing is struggling to make sense out of it. So people are trying to use more of the AI techniques. Right? So at the end of the day, I don't think I actually have a slide on that here, but you should remember that artificial intelligence, right, is just a set of problem-solving techniques. At the end of the day, right? I mean, we can read whatever you want about Terminator coming and all that, but it is really not more than a set of problem-solving techniques. Just like you have, for calculus, right? So or you have matrices. You can solve equations, systems of equations using various kinds of linear algebra techniques. So just like that, so the AI is a set of problem-solving techniques. Right? So I'll talk a little bit about what exactly is a problem that we are trying to solve, right? But there is nothing fancy about it, right? No humans were harmed in the making of AI like Frankenstein. So this is a talk I gave at a conference on epigraphy. You know what epigraphy is? How many of you have heard of the term epigraphy? EPI, epigraphy? Close, writing, right? So people who study Indus Valley scripts and so on and so forth, right? So they are epigraphers. That's the thing. So this is an example I gave where people are using AI techniques now. So there is this whole field called computational epigraphy, right? So where people have started using a lot of AI techniques, specific AI tools that have been built to help people understand ancient texts, right? So the number of fields in which AI is creating an impact is amazing. So this is aerospace, right? And of course healthcare. So AI is doing a lot in the healthcare space. So this is actually a very cool project. So have you guys read about something called the Loon project from Google? Loon, Loon. What was it about?
They built a series of hot air balloons and they launched them into the stratosphere, and they were built such that they could provide internet access and connectivity directly to remote areas. It was first tested by a group of people in New Zealand and later was used to provide access to the internet to a school in Brazil, I believe in Sao Paulo. I'm not sure about the city.
Yeah, so they did a bunch of different experiments with that, right? So one of the big challenges for Google was, how would I position the balloons in the right part of the world? So literally they were having these hot air balloons that needed to travel over the entire globe so as to give proper internet coverage, right? So they had to figure out how to send the balloon to a particular place. Balloons don't have a whole lot of driving power on them, right? They basically float in hot air currents. So how they steer balloons? Hot air balloons? How do they steer hot air balloons? They go up and down the atmosphere because currents flow in different directions at different levels in the atmosphere, right? So they have to go up and down. So they actually built an AI system that learns how to move the balloon around the entire globe. So that is how they were positioning the hot air balloons to give internet coverage. Unfortunately, they couldn't figure out a way to monetize the whole thing. So the Loon project is right now shut down. So it's no longer functioning. But that was a very cool piece of, it's an area that I work in, something called reinforcement learning. So it's really nice for me to see that it's solving not just toy problems, but something that is really world scale. Navigating a balloon to anywhere on the globe. That's cool stuff. But anyway, so let's get back. Need new batteries. So AI is not new, right? So the term AI was coined back in 1956, right? And so this person is widely credited with have started people thinking about, at least the computational community thinking about AI, right? So before that, a lot of philosophers were thinking about AI. In fact, if you look at the history of AI, some of the first people who got into AI were philosophers and even economists and people who were thinking about how humans think. Right? And those were the people who got into AI to begin with. So Alan Turing asked this question: can machines think? Right? So anyone know what's the name he gave to the answer he came up with? Okay, so he came up with something that people today call the Turing test, right? So he came up with something that people call the Turing test today. So the idea here is you put a computer in a room, a human being in another room, right? And a second human being comes in. He doesn't know which room has the computer, which room has the human. Okay, and he's supposed to ask questions of these two rooms, and just from their answers, right, should be able to say which is a computer, which is a human. And if he is not able to say that with certainty, then you say that the computer is truly intelligent. And now in today's parlance, you will say it has passed the Turing test, right? But Turing was not so full of himself, right? So he never called the test Turing test. Any idea what he called the test? So there was a movie made on Alan Turing's life. How many of you have seen that movie? Okay, you probably broke some laws while you saw the movie because it's not meant for kids. But anyway, but anyway, what was the name of the movie? That's what Turing called the Turing test. So that's where they get the name of the movie from, right? So it's he called the test the imitation game. So can the computer imitate a human enough to fool another human that it is intelligent? Okay, so that's basically what it is. I apologize. This seems to be low on battery. So the term AI itself, right, was coined at this event called the Dartmouth conference, right, in the summer of 1956, right. And if you look at it, they basically wanted to study if you can, write down the process of learning in such detailed manner so that the computer can be made to simulate it. Right? They were not asking for a computer to become intelligent or anything, right? Because it's not, nobody knows what that really means, right? So what they actually were shooting for, this is really the goal of the field of AI, right? They were shooting to make every aspect of learning, right, in a very systematic manner, write down every aspect of learning and intelligence in a very systematic manner so that the computer can simulate it, basically fake it, right? So it's not that they were trying to make something intelligent, right? So some pictures here, if you ever get there. So these are the people who participated in the AI conference. Right? So we have all amazing people who have contributed a lot to AI, right? So some of these names might be familiar to you from other contexts, right? So you have Shannon, who invented all of communication theory, right? So if you are able to, use your mobile phones nowadays, right, the core of it goes back to Shannon, right? So Shannon invented, rather not, I shouldn't say invented, but he is the founding thing of communication theory, information theory, and all that. Right? So a lot of amazing people, and each one of these in the blue circle went on to win what is called the Turing Prize, right? So the Turing Award is something that is given to, it's like equivalent of the Nobel Prize for computing, right? So each one of these people in the thing went on to win the Turing Award for their contributions to AI, and Herb Simon actually won a Nobel as well. Right? The only Turing Award to win a Nobel Prize. Guess what he won his Nobel Prize for? No, there is no Nobel Prize for biology. There's a Nobel for medicine, right? There's none for biology. But anyway, what did he win? No, he didn't win it for medicine. Yeah. Economics. Yeah, that's the closest you can get to as a computer scientist. So Simon won it for economics, right? But then there's a lot of very smart people contributing to this happening, and then a few more out there who didn't attend the conference but who are as instrumental in this field developing into what it is today, right? So that's the history of when AI started, but real AI success is also not new, right? And this is a person in the picture, this is Arthur Samuels, right? He wrote a computer program that learned to play checkers, right? He didn't write a program that played checkers. He wrote a program that actually learned to play checkers from scratch, right? All it was given was the rules of the game, right? And it learned to play by repeatedly playing the game, right? So it's like amazing that he managed to do it back in 1955, and he went on live television in 1956 and played a game, right? He was so confident that this thing will do so well, right? So he went on live TV, and all these big things that you see at the back, right? That's basically the computer that they had to put together to play checkers back then. Of course, they didn't put together for it to play checkers, right? And then ELIZA, oops, not there, here. So ELIZA is kind of what they call an expert system, right? It can answer all kinds of questions, right? And they built this to act as an assistant to a doctor, right? So you could ask it any kind of questions on your health conditions, and it used to answer this. And they were actually selling it as a mass product, right? So they had come to a point where they thought they can sell this as a product, right? So not that you can, not quite talking to your phone, but you could still interact with ELIZA, ask it questions, and so on and so forth. Right? So that's the way it is. And people of my vintage, when we went to school in the 80s, right, we remember advertisements for fuzzy control washing machines. Right? So in India, they were selling these washing machines in India, saying that, hey, look, you can. Of course, back in those days, nobody in India thought, why you need a washing machine? Don't humans wash clothes? But they were still trying to sell this here. Obviously, didn't take off that well. Right? So not just success, but AI hype is also not new. So here is another quiz for you guys. Look at the quote. The Navy revealed the embryo of an electronic computer today that it expects will be able to walk, talk, see, write, reproduce itself, and be conscious of its existence. So when did this newspaper story appear? Roughly. 80s, 2000s. Well, 2000s, it might have appeared in the 2000s also, but when did it first appear is my question. So that is how AI has always been hyped, right? So we go back to 1958, to see all of these kinds of things. So that's the reason why AI has always had this problem, right? So how many of you heard the term AI winter? AI winter. Winter, like summer, winter, In what context? Okay, I'll have to disabuse you of that. What you said you had heard of AI winter?
Yes, sir. Similar, sir. When there's a period of not much like development, when the development is stagnated.
See, if there had not been much development in the period, we would have never gotten out of the winter. Right. So what happened during? Yeah,
It's less about development and more about like the public image of AI, where it's like not seen as.
Yeah. So basically, what happened was, people stopped funding AI research because of this hype. Right. There was elevated expectations of what the AI can do, and when AI started failing, see, people said, "Oh, no AI in my products." Right. So I will not give you money to do more AI research and things like that. But people are still soldiering on. People are still doing discoveries. And that is the reason we keep coming out of these winters. There was an AI winter back in the 60s, right? So what happened then was, this particular article, right? This was written about a specific AI system, which people showed could not solve a very simple problem called the XOR problem, right? So let us take so people know about binaries, right? So let's take, so there is 0. There is 1, right? So the XOR problem says if both the inputs are the same, right, you say it is 0. The output is 0. If both the inputs are different, the output, okay, you can even make this sometimes, right? Both the inputs are 0, the output is -1. Both the inputs are different, the output is +1, right? So people showed this particular AI system, right, which people expected it to be conscious of its existence and so on and so forth, could not solve this, right, could not learn how to represent XOR solution, right. So then they said, oh my God, this is so dumb, right. So if you hype up things too much, this is what will happen, right. So then the whole field went into nosedive. So around this, the people showed this in 69. This was in 58. So from 70 till about 69 to 83, right, there was not much progress in terms of visibility and funding and so on. So people are still working on it, trying to solve this problem. People knew how to solve this problem, right? They just didn't know how to make a program out of it, right? So people knew what will be the solution. They didn't know how to learn the solution. That was the challenge, right? And then people solved it in 83, and then 83 again you saw a boom, right? And that lasted till about 95. And then it went again into winter. So it's not like each of the quote unquote AI summers lasted only 5 years, 6 years or something like that. They lasted really, really long time, right? Each season really lasted a long time. So the first summer went from like 55, 56 all the way to 69. Right. The next summer started in 83, went up till 95, right? And then again we went into a winter, which lasted fairly long until about 2012 or so. And then from 2012, we have been seeing another upswing for the last 12 years now, right? So be wary of hype, right? So now today, as you saw in the beginning, right? So what is different about this particular upswing of AI is how commonplace AI has become. Right? So earlier generations of success stories of AI and all that, right, were like one-off successes. Right? And IBM could create a machine that will play checkers. Right? It's not like it's coming out of your pocket, right? So it's not like running on the phone and things like that. A lot of things have changed since the first round of AI success. Today, like we polled in the beginning, right? So even in this room, there are several of you who talk to AI on a daily basis, right? So it's become very commonplace now, right? So that will, I think, ensure that we don't really go into a winter. We might get an autumn where things cool down a little bit, right? But we'll never really get into a winter. Right? So I'm going to try and talk about what. So just so you guys know, I'm not going to give you a break after my first hour. Just keep going to go because I have a class at 11. So I'll have to end early and leave for my class, right? So I'll keep going till 10:50. Okay. Yeah. So try to break it down into different components, right? What exactly constitute intelligence? So in some early versions of this talk I used to give, I used to ask people, do you think, playing chess, does that require intelligence? Do you think, going shopping, does that require intelligence? How about recognizing whether a baby is a boy or a girl? Does that require intelligence? I have been giving this talk for a long time. So when I used to give this talk, it turns out that computers were great at playing chess, right? And you can, with some little difficulty solve the shopping problem. But they used to suck at telling apart, boy or girl, because the gender, not the gender problem, vision, right? They were very bad at vision. And of course, very bad at hearing and so on and so forth, right? So a lot of things that we take for granted, which we think doesn't need intelligence, turns out to be things that we actually use a lot of intelligence to process. It's just that we don't do it consciously. Right? So it still needs a lot of brain power to process many of these things. But then technology got ahead of ourselves, right? So now that example doesn't make that much of a sense because computers are great at doing vision now, amazingly good at doing vision. So I started reorganizing these things into what really constitutes intelligence, right? So there are these 4 components. Right? The first one is perception, right? This is where the vision part comes in, right? So the perception, right, and ability to see the world, hear the world, feel, touch, so all of these, right? So the inputs that you are getting, right? That's the perception part. And to actually do that in a meaningful manner, right? So what are you getting? You're just getting a bunch of, photons striking your eye or, sound waves hitting your ear and so on and so forth, right? How are you making sense out of it into objects and words and noises and so on and so forth, right? So that actually involves quite a bit of processing, right? The second piece is what we call cognition, right? So cognition is about understanding all the sensory inputs that you're getting, right? So taking in this room is one thing, but trying to understand that, okay, this is a classroom in which somebody is talking and so on and so forth, right? So that is the cognition part. So this perception part would be to say that, okay, there are, a bunch of people who are sitting around and things like that, but actually, making sense out of the scene, right? That's the cognition part, right? So AI systems were, even after they became great at perception, they were struggling with cognition for a while. Then you have reasoning and decision making, right? So you have all the inputs that you want. You've understood what is it that is happening and what you want to do, and you still have to think about the problem. How will you solve the problem and how will you make decisions, right? So that reasoning and decision making is something that early day AI systems paid a lot of attention to. Right? So there's a lot of work that has been done in following that. In fact, if we go back to the 60s and the 50s and 60s and 70s, a lot of work was done on solving the reasoning and decision making problem. So why do you think that is? Because we thought we understood how humans reason and how humans make decisions. We thought we understood that in much more detailed manner than we understand perception or cognition, right? So if I ask you, I don't know, man, I'm bad at colors. Okay, is that blue, right? You will say yes. Why? Sorry? Yeah, but it's very hard for you to actually write it down in a systematic manner why something is blue and why something stops being blue, right? So it's hard, right? So so that's the thing. So in the early days, people were actually trying to look at how humans thought, because the beginning AI's goal was to understand human intelligence, right? They were trying to understand how humans used to think and try to systematize that and write AI programs that will solve the problems that way, right? So they were able to get to the decision making. If I ask you why you made a move in chess, you can tell me, right? You can say, oh, I'll move this way and that guy is going to respond like that and I'll get some piece advantage or whatever, right? So you can describe that to me in lot more detail than you can describe why something is blue or green and so on and so forth. So that was the reason we made a lot more progress in the reasoning and decision making part of AI and not the other components to begin with, right? So we really needed the advancement to come in the fourth component, which is learning and adaptation. Right? So in fact, not just in popular imagination, even among the AI researchers themselves, so reasoning and learning are considered as higher intelligent functions. Right? So you really want your machine to succeed in these two to be called as intelligent, right? So you don't want a machine that can identify every single object you show to it as an intelligent machine. You don't want to call it as intelligent, right? Even though it turns out that that's where AI has had huge success, but you don't want to call that as an intelligent machine. What you really like to call as intelligent is if you can reason and you can learn, right? So a lot of effort went into reasoning and learning, but it just so happens that we also are not very good at describing how we learn, right? So we didn't make a whole lot of progress in the learning part also to begin with. So we came up with all kinds of approximation. I'll talk about that, because most of my talk will be about the learning piece, right? So the first thing to understand, right, AI is not a single technology. Right? AI is a collection of solutions, collection of methods, collection of optimization techniques, and a lot of different math background that have come together. And people have just started labeling all of these as artificial intelligence, right? It's not a single thing, right? So for perception, right, whether you're doing computer vision, right, which is identifying objects in a picture and so on and so forth, or speech processing, or natural language processing, right? So all of this, so you read a piece of text, right, or you listen to something, you see something. Each of these is requiring a different kind of technology to solve, right? It is not like that's a single thing. We're getting there. We're getting to models that can do all of these together, but it's not quite there, right? So there are different set of tasks that you have to solve in each of these, and so it's not a single technology that quite does that all the time, right? It's okay. I'm just looking at. So this is a picture from a contest, right? The competition that used to run is called ImageNet. So there were 1,000 different categories, right? So each has a certain number of pictures associated with it, and your goal is, given all of these samples, if I give you a new picture, you have to tell me what is there in the picture. Okay, make sense? And about 2015, AI systems started doing it better than humans. So that's the human error rate. The red line is the human error rate. The AI started doing better than humans in 2015. Something similar happened with speech recognition also, right? AI systems started doing better than humans circa 2016, 17, right? So people declared, oh yes, AI is having great success in doing perception, and we can go ahead and start using these systems more reliably, right? And then again, cognition, right? Scene understanding. What is there in the picture, right? Or speech understanding, natural language understanding, trying to understand, say, things like idioms and sarcasm and all these things, right? And also having free-ranging conversations with humans. All of these things are very challenging for AI systems, right? So it was a work in progress until very recently. So is there any breakthrough in AI you guys have heard of in recent times, happened in the last year or so? ChatGPT, last year or so. Neural networks have been around for, yeah. So when was the first neural network proposed? Any thoughts? It's the 30s actually. So So there is this model of a biological neuron, mathematical model of a biological neuron called the macula-Pitts neuron, right? That was proposed back in the 30s. And literally all the modern neural network actually can trace back to that original, mathematical characterization of a biological function, right? So, like, I mean, if you think about our level of understanding in the 30s, for somebody to make that leap was a significant advancement.